Hello everyone. Today we will be doing Leetcode question number 935 night dialer. So here we have given a chessboard, and on chessboard there is a knight which can move in 8 directions, and 8 directions in such a way that it can move two squares up, then either right or left. It can move two squares down and either left or either right, and from horizontally it can move two squares, and then from there it can move up or down, and similarly on the left two squares and up one and down one. So totally in this way we have eight types of movements for this night dialer. These are the movements of the night. Then we have also given a dial pad here. On the dial pad, the knight can move on any dial pad here, but it cannot stand on red color dial pads. On star and hash, it cannot stand on this. Apart from this, it can stand on any number which are in the blue color. And also uh, the knight can move in any directions as per the movements here on this dial pad. So let's go to the question, what it is saying. Given an integer n, written how many distinct phone numbers of length n we can dial. And also you are allowed to place the knight on any numeric cell initially, and then you should perform n minus 1 jumps to dial a number of length n, and all jumps should be a valid knight jumps. So for example, if the given number n is 1, if n is 1, then jumps we can perform is n minus 1, that is 0 jumps. If n is 2, then we can perform n minus 1 jumps, that is 1 jump. If n is 3, then we can perform n minus 1, 3 minus 1, 2 jumps only. Similarly, if 4 is given, then we can perform 3 jumps per cell. So what we will be doing is we will keep the knight on each and every cell on the blue color cells, and we will calculate the number of distinct phone numbers we can form. For example, if n is 1, then we will put the knight on the first cell, and if n is 1, the jumps are 0, we cannot move anywhere from here. So jumps are 0, so this is the phone number, 1 is the one phone number. Then we'll put on 2, and 2 is the phone number since we are not able to make any jumps. um, Next we'll put on 3. So in this way, if n is 1, we are able to put the knight on each blue cell, so we have 10 output here. 1 2 3 4 5 6 7 8 9 and 0. We have 10, so the output will be 10. Similarly, if n is given as 2, then we'll have one jump per each cell. For example, if the knight is placed on the first cell here, it can move from 1 to 8. This is one jump. It can make only one jump if n is 2. Right, if n is 2, we can make only one jump. So if it is present here on 1, then it can go to 8 according to the movements here. It cannot go upwards, it cannot go lefts. It can also go on the right side. It can go on to the 1 to 6, 1 to 6 and 1 to 8. These are the two ways it can go from 1. Similarly, if it is placed on 2, from 2 it can go to 7, it can go to 9. These are the two ways. In 3 it can go to 3 to 8. On 4, from 4 it can go to 4 to 3, and 4 to 9, and 4, not 4 to 9, it 4 to 0. It can go to 4 to 0, and it can go to not on 4 to 3 as well. It can only go to 4 to 0 or 4 to 9. So these are the two ways here. Similarly, if it is placed on number 5, it can go to uh, 5 to star, no, we cannot go. 5 to hash, we cannot go. So on the top also we cannot go, on the left, on right, we cannot go. And if it is placed on 6, we can go from 6 to 0 and 6 to 7. So in this way, we have total 20 outputs. Here we can see we can go to 0 to 4, 0 to 6, 1 to 6, 1 to 8, 2 to 7. These are all the outputs we can get if n is 2. Now coming to n3. N3 is we have to find a phone number of length 3, and jumps are only 2 per cell. Let us see how we can do that. If it is placed on 1, okay, we have 2 jumps left now. So 1 to 8 we can go, right? 1 to 8, and from 8 again we can go 8 to 3 or 8 to 1. Suppose we went from 1 to 8 and 8 to 1. This is one combination. And 1 to 8, and again we have two jumps, right? So 1 to 8 is one jump, and 8 to 3 is another jump. So 183, this is one combination, and 181, this is another combination. So this is how we will do if n is given as 3. Let's see for 2 here, the cell number 2. From 2 it can go to 2 to 7, and from 7 to again 2, or it can go to 2 to 9, and from 9 to again 2. Since we are able to make two jumps for n is equal to 3, the phone numbers we got is 292, 29, um, yeah, 292 or 272. So like this we will calculate for each cell here, and finally we have to return the answer modulo 10 power 9 plus 7. So let's think of the logic. How can we do it? How can we do this? We can apply recursion. Why? Because see, from 1 we are going to 8. If n is equal to 3, then we have to move again from 8 to uh, we have to check the from 8 to 3 or 8 to 1. We are doing the same work in each step. The only thing which is changing is the row and column. Initially it was 1, and then it is 8, and the number of count. For n is equal to 3, we are going from 1 to n is equal to 3. We have two jumps from 1 to 8. From 8 we are going to do the same work again, but with jumps left is only 1. So we are doing the same work. The only thing which is changing here is the row, the column, and the number of counts. So we will be going with recursion, a function calling itself. So let's try to write the logic. So initially we have row is equal to 4, and in columns are 3. And now we'll take a for loop. We have to traverse through each cell. So let's traverse through each cell. 0, I less than number of rows, and I plus plus. Now through column we traverse j less than c, j plus plus. Now we'll take a variable called int as answer. Let's take it as long, since the answer can be large. Then answer is equal to answer plus, let's take a method as a calculate. Calculate. Here we will be passing the row number, that is I, and j, and count, so unt. Count, since these are zero and arrays are zero based index, we will be doing count minus 1 here. Now let's go writing the calculate function. This will return long calculate int r, int c, and int count. Now what are we doing is whenever we are on each cell, we are going to all the other 8 possible options. We are going to all the other 8 possible options. So let's write that possible options one by one. Calculate row minus 2. If we going 2 rows up, then column minus 1 and count minus 1. We should do modulo. So let's write mod is equal to, mod is how much? 10 power 9 plus 7. 1 2 3 4 5 6 7 8 9 7. So whatever we get, we mod it. We'll add it again with what? Calculate row minus 2 column plus 1 count count minus 1 percentile mod plus. So we have from 8, for example, we count 2 rows up and 1 column minus, 2 rows up and 1 column plus. Let's try to go through column now. Calculate. We will go 2 columns next, column plus 2, and then row minus 1, comma, count minus 1, percentile mod plus calculate column plus 2, row plus 1, and count minus 1, percentile mod plus. Now let's copy this 4 again and change the values so it will be fast. Now row plus 2, row plus 2, and column minus 2, column minus 2. So we will return the answer whatever we get from here, but we have to give some conditions as well. For example, if row is less than 0, or if row is greater than equal to 4, or if column is less than 0, or if column is greater than equal to 3, then what we'll do, we'll just return 0 because these are invalid conditions. If Now we will check these conditions. If the night is on this red cells, here the column number is 0, if c is equal to 0, and row is equal to 3, or if row is equal to 3, and column is equal to 0 1 2, column is equal to 2, what we'll do, we'll return 0. Similarly, if count is equal to 1, we will return 1. If count is 1, if count is 0, we will return 1. For example, if the n is 1, then count is 0. So it will call the calculate method. It will be on the first cell and it will return 1. Similarly, if it is 2, on the 2, it will come to this calculate function. If this will be count will be 0, and it will return 1. In that way, since we are passing count minus 1, here count is nothing but n. Count is equal to n. So this is the recursive function. Let's try to run this code. We are not returning the answer from here. Return answer. Let cast it to int. Okay. Initially the answer will be 0. Now let's try to run this. We got compilation error. We have not given brackets. We got wrong answer here. Yeah, the mistake is here. If r is greater than equal to 4. Now run. It got accepted. Let's try to submit it. But we have made one mistake here. In place of column, we have written rows, and in place of rows, we have written column. So row minus 1 and C plus 2 here, column plus 2. Similarly, row plus 1 and column plus 2. And here as well, row minus 1, column minus 2, row plus 1, column minus 2. Let's try to submit this. It got submitted. Let's see. Time limit exceeded. We are getting the option time limit exceeded here. Now, why are we getting the time limit exceeded? Because we are calculating the um, same cell again and again. For example, let's go back to the question here. If we go from 1 to 8, from 3 to 8 also, from 3 also we can reach to 8. So from 8 again we will be going to 8 to 1 or 8 to some other place. So let's try to store the 8 value. For example, if 1 to 8 we calculated, from 8 to again we are going to somewhere, then in it we'll calculate the 8th result beforehand. So if 3 also call the 8 here, the answer is stored. This is what dynamic programming is. Let's try to understand this. Let's take an array here, long three-dimensional array. Why we are taking three-dimensional array here? Because um, in recursion there are three values which are changing: r, c, and count. So we'll be taking it. Let's take it as an array itself is equal to new long of r, c, and count. Now we will pass this array to this calculate function. Okay, let's try to replace it everywhere and in all these functions as well. Now we have replaced. Now we will store this in the array only. Array of r, c, and count. Now here initially we will check if this value is greater than 0, then means it is already calculated. Then we will just return it, or else we will calculate, and finally we will return this method, return this value. So this is what dynamic programming is. We just calculated. If it is greater than 0, we will return it. If it is not, we will calculate and store it. Okay, let's try to run and submit. Sorry. Count minus 1, comma array. Let's try to submit it. Now let's see the result. It has given the wrong answer. Let's maybe we haven't kept the mod somewhere. We have missed the mod. Yes, here percentile mod. Missed the modular there. Okay. Let's try to submit. It got submitted. So this is the question of night, Tyler. Thank you. Thank you for being patient. Please like, share, and subscribe. Thank you.